So I will do a brief introduction, well, 20 minutes introduction in English, but of course you can ask me in Spanish, Catalan, Korean, wherever, about the stuff we are going to be working with in the workshop. The workshop is about customer segmentation. This is actually, segmentation is more like a marketing thing. For us programmers, it's more like customer clustering. But I have to sell this to my boss, so I have to use his words. Thank you for the sponsor, you know them. This is me. I have been developing websites the whole 21st century. Last 2 years to Box, which is an online supermarket, in the case you don't know it. And I like machine learning. I'm not an expert. I'm just a hobbyist. This is my hobby. So perhaps I cannot answer all the questions you're going to ask me, but we will try to. And this is my, Twitter, Instagram, whatever. So this is the most important thing you should be downloading, especially the Docker container. And machine learning is actually my objective for this year. It's like at the beginning of this year, I tried to set a focus point on something, and I decided that machine learning should be interesting to learn and to practice. Basically because it's the new hot thing, but for me the point that changed things was last year AlphaGo beating EZ-all. I don't know if you know about this. Anybody knows? No? Yes? No? No? Okay. Is this game, this is the game of Go. This is actually EZ-all is the strongest player in the world. I have met him personally, so I know, because I play Go, actually. I'm in the top 10, top 15 in Spain. So for me, it was an incredible thing. And the thing is, like, usually every 5 years, you have a new hot thing, like it was mobile first, big data 10 years ago. And then 5 years later, not so many people still speak about big data or these things. But I have the feeling and the intuition that machine learning is going to stay with us. And every programmer should end up learning machine learning and using it, because you can apply to so many different things that you can avoid it. So I have some university background, but I need to learn more, and I try to learn starting with the famous Coursera videos. It didn't work for me. And actually later I tried with books, and it depends the way you learn or you prefer learning. And learning is a good thing, but I have to find an excuse to apply it. And the problem is, like, I'm not the kind of late night hacker that don't sleep and try things, but I'm mostly a person that when arrives home, he wants to enjoy time with his girlfriend, his cat, wherever. So I have to find some excuse at work to use machine learning. And I found one last year, at the end of last year, which was in Box. We have a business analyst department, 3 people who are not programmers, so they do some kind of business analysis with Excel, which is like the devil. It's the worst thing I have ever seen. And they do some kind of analysis looking for, how to say, trying to make business reports. But this is not useful. It's useful for the company in the sense, like they try, for instance, to segment customers using the periodicity of orders and the amount spent in each order. And this could be interesting for like the CEO or CMO or CFO, but for people like us, programmers, that we have to try to improve the, for instance, the user experience, it's not a good segmentation. Actually, the real problem was like we have a customer relationship management department in Olabox, and the girl who is the boss in that department asked me about this, like, okay, I have this kind of customers, but you know, when a customer calls us, like, we have to hang the phone and say, okay, what's the problem? But in like 3 seconds, I have to know which kind of customer is. And what you cannot do is like you have no time to enter the back office and see, okay, this customer, okay, this customer is buying drinks, he's buying things. It's like, no, you have to, at sight, know which kind of customer is. So I said, okay, that's a good idea, and we can actually use the last orders of this customer to get some idea of which kind of customer is. So I tried to apply this, let's say, this buying behavior clustering orders. So we will be clustering orders, not clustering customers. It's a bit small difference, but at the end it's like, if you know a customer who is buying or his last order was this and the previous order was this, you can get a better idea about him. I will introduce briefly some general concept of machine learning in the case you haven't seen them. Basically, the modern method to apply machine learning is like you have some base data, you use it to create some model. The model is like you input the data, you choose some algorithm, you tune this algorithm, you test this algorithm is going well, and when you see that this model is like predicting correctly things, you try it with new data. Like you deploy this model, because it doesn't make sense that you create a model and then you don't use it in production. In the sense, the real use of a machine learning model is like to use with new data, so you can predict or you can get information about the new data is coming from the future or the present. So actually, these 5 steps, like cleaning the data, choosing which algorithm use, turning that algorithm, deploying a pipeline with the model so it works in real time, and then updating the model with the new data is coming, are really the 5 steps we usually do in machine learning. And the problem is, when you read about machine learning, you normally know about this part, which is like, oh, you know, it's a new algorithm, it's called random forest. Oh, wow. But you have to do the rest, which is not that funny. In machine learning, we have basically 3 types of problems. Supervised problems, which is we have some data and some labels, and we have to predict with new data as the label. I will show you an example later. In this workshop, otherwise we will be using unsupervised, which is just giving data and finding shapes in the data. And also another way to learn is with reinforcement, where you give the model a way to know if the result is good or bad. It's like in the AlphaGo case, they use this. But it's not that common. For supervised learning, it's quite easy. It's like you give the model a picture and you say, it's a cat. You give the model a picture, it's a cat. You give a model a picture and you say, it's me. And then you test the model and say, okay, what's this? Quite easy. For the unsupervised learning, you give this, and this. And there is no test. And this is kind of, oh, what the fuck? What is the model going to do? That's the funny and difficult thing to understand, in the sense like, okay, what could I learn from these pictures? It's like, okay, there's some kind of animal. Perhaps in some pictures you see the face, in some pictures you see the complete body. I don't know. It's like you try to, as a human, try to extract features. Like, okay, we have a picture here, a full body here, but this kind of learning just shapes. So it's the unsupervised learning basically is trying to extract features without telling the model about them. So try to find similarities, different things. And this is, there is one famous machine learning, general artificial intelligence person called, I forgot the name, it's Jeff Hinton, who is basically the inventor of the deep learning and this kind of stuff. And he said this is the future, because it's a bit more difficult, but the results could be amazing. And one of the examples of the results is like this. It's like if you teach some machine model to learn what is a zebra, and then another one to learn what's a horse, and you start with a picture of a zebra and do small modifications until the second machine learning algorithm say it's a horse, you can get this kind of funny things. We are not going to do this anyway. We are just going to do clustering. But you can use this to anomaly detection, to dimensional reduction, to a lot of, to get the shape of something and then project this in the future. It's like if I know the shape of an order, I could predict future orders in base of this shape. So it's quite useful, but it's still a kind of difficult to understand thing. So clustering is like basically grouping, but you can use this also for quantization, like for instance colors or things. And we will be doing in the workshop, we will be trying two algorithms. It's k-means and dbscan. K-means is just really, really easy to understand algorithm, which basically is you start, let's wait to interaction 1. Come on. Oh, 0. Okay, we are programmers. 0. So you start to random centers, and in each iteration, the center moves slowly until a point of convergence. This is good because it's like quite easy to, at the end, the center is showing like this is yellow, this is red. There are 3 groups. But the problem is, first, you have to tell the algorithm there should be 3 groups there. So it starts with 3 centers. And the second thing, if you see, this is kind of Mickey Mouse shape. So actually, some points here could be part of this group and not part of the Mickey Mouse era. So it's not that perfect, but it's quite easy to understand and quite useful. The other one we will be trying is dbscan, which is density-based spatial clustering of application with noise, which basically is like tries to find similar density spaces. Also, this is 2-dimensional spaces, but usually we will be doing like several dimensional space. And the problem here is like it's easy to understand, but it's not easy to tune, because it's like you have to tell the algorithm what's density. Density is this should be at least 1 point distant from that. How many samples should be in a group to consider it a group? The good thing, on the other hand, is that this can show you outsiders like this, like, okay, this is not part of any group. While the previous algorithm, k-means, will try to set this as part of this cluster, for instance. Ready? No. No, there is a problem here. The problem is, I told you, like, oh, there are 5 steps, and I spoke about, I told you about the second step, the algorithm, and the funny part, but we have to start with the kind of boring part, which is not boring at all, which is data preparation. It's like we have some data. Actually, you should be downloading some Ulabox data set with orders, with 30,000 orders, I think. And first we have to see what's the data, because it's like the analogy could be when you want to teach a baby, you have to choose some good examples for the baby. It's like if you just try to teach with random examples, perhaps he's not going to learn as fast as you want to. So for the computers, it's the same thing. Basically, you need to, most of the algorithms try to, or expect all the features to come with values between 0 and 1. So they are optimized for this. But also it's like, for instance, here you have like the same order of magnitude here and here. And it makes no sense that you have here from 0 to 1 and here from 0 to 1 million, because when you are going to like calculate the distance between this and this, will make no sense at all, because it will mean not here, here, but here and 1 million meters or over there. So it makes no sense. Also remove noisy cases. We will see one example in the workshop, and other processes which are kind of boring, so I will not explain. And also really, really important, and perhaps the part which takes more time, is exploring the data. It's like try to show or to plot the data to see what's the problem, to see the shape of the data before showing to the algorithm. It's like it's not the, and it's really important to see in images, because we are humans, we are visual learners, so it's not the same that somebody tells you, we get more orders at 22, like at 10 p.m. Okay, here. But if you see the pictures, like, okay, this makes sense because people are sleeping, and then suddenly what happens here? What the hell is here? It's like, okay, this is Spain, people should be doing siesta or something. I don't know, why the hell suddenly like at 2 or 3 p.m. we stop selling it. And this is the second part. It's like you have to ask when you see this kind of thing, you have to ask the domain expert or the people who provides the data. Because in this case, it's like in Nullabos website, if you order, well, if you order an order up to 2 o'clock, you get the delivery the following day. Otherwise, you get the delivery 2 days later. So people buy and suddenly, oh, I will get the delivery 2 days later. I will not buy. These kind of things happen. This is the last one, which is while doing this, I learned like it's really important, again, to explore and optimize data. You have to find the features that count, because it's like usually the data provider will give you a lot of data and some data makes no sense. It could be making sense, or you have to do some engineering, like, okay, if I know this edge case, perhaps I can add another feature that is, what's the order before or after 2 o'clock? Something like this. On the other side, we have to avoid what they call the curse of dimensionality, which is like, okay, we have 400 different features. We will input them in the algorithm. That makes no sense, because the algorithm will take, I don't know, centuries to find something useful. So it's really interesting that to start small, start easy and useful. And I will tell you an example. It's like one day I was speaking with one of these business analysts, department person in our company, and I told him, okay, what are you doing? Oh, no, I'm trying to calculate the churn. The churn is like if some customer will repeat buying. And say, okay, what are you doing? Well, you know, we have 400 features and we are throwing that data to the algorithm. Say, that makes no sense. No, but it's kind of difficult. It's like, you don't have an easy insight to start with. Oh, yeah, of course. If somebody orders like 200 euros or more, he will usually buy again. So, okay, then we can program this. We can use this. We can know that if somebody is adding items, and it's over 200 euros, you don't need to give him any promotion, because he will end up buying. This is not really ethics, but you know, this is business. And the last one is like, it's really, really easy to find skills at work to try different algorithms, to try different ideas, because usually bosses now because it's the new hot thing, the bosses could tell like the investors, you know, we are using machine learning. And on the other side, usually the results are quite interesting. And it's quite easy. Actually, I have used, at Toolbox, we have used machine learning from stupid things like estimating the number of boxes your order will have, instead of, okay, you order this, and this, and I know this is like 1 meter long, and then if I put in a box, no, this is a really complex calculation. Okay, you have spent 200 euros in this and that, should be 2 boxes. Things like this, or what we will be doing in the workshop, the customer segmentation. So now it's time for you to do and for me to shut up. Question?